Good evening, everyone. Hope all of you are well. Today, we're going to discuss about a very interesting topic, Z transform. It is vastly used in digital signal processing. For today's class, we'll take help from the slide prepared by our course teacher, my course teacher, MD Apple Mahmoud Pranto sir, lecturer, Department of ICT, BUP. So let's get started. First of all, we'll look through the definition of Z transform. The Z transform is the discrete time equivalent of the Laplace transform. It converts a discrete time signal xn from the time domain into a complex frequency domain. So xn converts into xz, where z is a complex variable. So we can denote Z transform xn, it is converted to xz, where z is a complex variable. It is a discrete time signal and it is the representation in Z plane or Z plane, Z transform. So why to use Z transform or Z transform? The main topic here, I can see that turns convolution in time domain into multiplication in Z domain. Convolution is comparatively a very harder task, or it takes time to solve, while multiplication is simple. So in Z domain, we are seeing the advantage of multiplication over the convolution. It also helps analyze system properties like stability and causality using poles and ROC. These two are very important terms we will discuss in this slide or in this class. So what are the applications? The applications are very important for theory questions. We can see digital audio processing. In audio there could be noise, there could be distortion. So by filtering those samples, we can have a clear audio. We can see image processing. A very dull image can be enhanced, can be compressed for size problem, age detection, and so many things can be done. Communication system, we can see we have already know about the modulation, demodulation, error correction in the control systems also, and especially in biomedical signal processing. We have also learned about ECG, EEG. So these are some of the real life applications of Z transform. Now the main part comes. In this picture, we are seeing a very clear representation of Z transform, where the x-axis is denoting the real part and this is denoting the imaginary part. So here we can see a circle. This is having a radius of 1. So this is called a unit circle. We are also seeing angular frequency, which is denoted by omega. One by one we will see these things. So here we already know z is a complex variable. So z can be represented as real part of z, j into imaginary part of z. So we know the term cos theta plus I sin theta. In trigonometry, we have used the term a lot. So this can be shortened by r e I theta. By using the formula, we can also represent this into this. R e j, I is replaced by j. We can also use j and omega. So here r is the radius, j is the imaginary part, and omega is the theta, or the angular frequency or angle of z to be exact. So here r equal to modulus of z. So what is the magnitude of is z? 1. The magnitude of z is 1. That's why it is called the unit circle. Now we will go to the region of convergence, which is very important. Region of convergence is the range of complex variables z in the z plane. The z transformation or z transformation of the signal is finite or convergent. So the transformation of the signal will be finite. So ROC represents those set of values of z for which xz has a finite value. The main important thing is the graph here shown. So in the first graph, we can see the all over the part of z plane, it produces the finite value of xz. So the ROC will be all z plane. In the second graph, we can see highlighted round shaped circle is denoting the unit circle, and into this circle we are also seeing a R1 radius circle. So here the Z transform will be greater than R1. In the third graph, we can see there is a circle of radius R2. Into the circle we are seeing the unit circle. So the ROC will be less than radius R2. And in the last graph we are seeing two circles, and between the two circles we are seeing the unit circle, and this middle part is highlighted. So the ROC will be greater than R1 and less than R2. These are the types of ROC we can find in later topics or later mathematical terms. So now we will talk about the mathematical term, the first math we are seeing here. So in order to solve the math, we have to know about the basic formula of Z transform. So what is the basic formula of Z transform? X of Z equal to summation, the lower part is minus infinity, upper part is plus infinity, x in z or z to the power minus n. This formula is very important and it is needed throughout the class. So here we are seeing the sequence representation of the discrete time signal. So 1 is pointing, so this is the 0, this will be 1, 2, 3, 4 and 5. So if we put it the formula, our lower term is indicating n equal to 0, these are the n, and higher part or the highest part is 5. 1, 2, 5, 7, 0, 1. So if I put x0, so the value of x0 is 1, so that will be 0. And x of n of x of 0, the magnitude of x of 0 is 1. Then the x of 1, the magnitude of x of 1 is 2, and n equal to minus 1. So I'm writing the later terms. Now z inverse 0, it is simply 1. It will be 2 z inverse 1. It will be 5 z inverse 2. 7 z inverse 3, and this is simply 0, so we will not write it. And at last it will be z inverse 5. So this is the answer, but we have to find the ROC. So what will be the value of ROC? Now talking of the ROC, we need finite values of xz. So to have the final value, we have to exclude the values like invalid or infinity. So if 2 by z, we are taking 2 by z, 2 by 0, if z equal to 0, somehow we are getting infinity, tends to infinity, which is invalid for this math. So the ROC will be simply all z plane except z equal to 0. Now let's look into the example number 2. So in the example number 2, we are seeing the arrow sign is indicating 3. So the n is 0 here in the middle part. This will be minus 1 and this will be minus 2. 1, 2 and 3. The rule or the formula is again simple. We're writing the formula for our simplicity. Summation of n equal to, here n, the lower part is minus 2 and the higher part is indicating 3, n3. So that will be, there will be xn and z inverse n. So if we put the value of x minus 1, minus 2 first, we are getting 1, the magnitude 1, z minus minus 2, so it will be 2. Then it will be, the magnitude is 2, z minus minus 1, so it will be just 1. The magnitude is 3, z 0, magnitude is 4, z minus 1. It will be 0, z minus 2, it will be 5, z minus 3. So the answer will be z square 2 z 3 4 z inverse 1 5 z inverse 3. Now we will solve the ROC or find out the ROC. So what will be the ROC here? We are seeing z as well as z inverse 1 or z inverse terms. We need to remember is there will be no infinity term. So here, if z equal to infinity or if z equal to 0, in both cases we are getting infinity. So z cannot be equal to infinity and z cannot be equal to 0. Except these two, all the z plane is valid here. So the ROC is everywhere except at z equal to 0 and z equal to infinity. So the answer will be all z plane except z equal to infinity, z equal to 0. This is the answer of ROC and this is the answer of the Z transformation. To further continue this class, we need to know about a very important term or formula or derivation. Xn equal to a to the power n unit function n. So what will be the Z transform of this? Let's derive. So the formula will be xz equal to summation of n equal to minus infinity to infinity xn. The xn is represented here as a to the power n unit function of n, and lastly z to the power minus n. Unit function. Unit function is generally represented as 1 when n equal to or greater than 0 and 0 when n is less than 0. The graph will be simply 1 1 1 1 dot 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 0 1 2 3, and these for the negative term, negative part, the value will be 0. Okay, so here we are considering n equal to 0 to infinity a to the power n. So 0 to infinity, for this range the value of un is simply 1. Then we can write this by this az inverse 1 all to the power n. Two of these are same. 1 plus az inverse 1 az inverse 1 square plus dot dot dot. So what is the formula? So the simplest formula or the general formula of it is 1 plus a square plus a cube. We'll simply then write 1 by 1 minus a. And also the important term is modulus of a will be less than 1. So we have to remember this shortcut on this formula also. So we can write this to this 1 by 1 minus the common part is a z inverse 1, a z inverse 1. Yes, then we can simplify it 1 minus a by z. Then the z term will be at top and remaining will be at the bottom, z minus a. So here the important part you should remind that a z inverse 1 should be less than 1. So if I simplify it further, at last it will look like this. So by doing this we have already found out the ROC. So the ROC will be modulus of z greater than a, greater than, it is greater than. So if we plot a graph here, so what will be the graphical representation of this? This is a circle which have radius of a. So it is indicating the ROC is greater than a. So ROC will be greater than the circle which is having a shape, a radius. It will detect the circle, and the rest of the z plane will be the ROC. So the ROC is simply z modulus of z greater than a, and this is the graphical representation. To move to the next part, we'll need to know about a formula. So let us consider xn equal to impulse response. We know this is represented by a functional representation 1 and 0. When it will be 1, n equal to 0, then it will be 1, and else everywhere it will be 0. So the graphical representation will be 1 when n equal to 0, and rest part it will be 0 everywhere. So if we do z transform here, n equal to infinity z minus n. So we know impulse response of n will be 1 when n equal to 0. So we need n equal to 0. So del of 0, z inverse 0. So it will be 1 into 1, and it is simply 1. So if we replace here the del n to del n minus k, so for what value of n minus k the whole will be 1? Simply n equal to k. If n equal to k, then the whole magnitude will be 1. So this is very needed for the next method. So the solve will be 1 into z inverse k. So z inverse k, or 1 by z to the power k. This is the answer, and the ROC will be except 0 entire z plane. How? If this is 0, then it will be infinity, and this is invalid for this purpose. So the answer will be except 0 entire z plane. Now moving on to the main topic, or the main problem. So this is the problem. It is a very important topic, very important problem. Here we can see the value will be a to the power minus n when n is less than or equal to minus 1. So it will be n equal to minus infinity to minus 1 minus a to the power n z to the power minus 1. So unit function of minus n minus 1 is simply here 1. Now we are seeing negative limit, but we need to convert it to the positive. So we have to convert negative limit to positive. How to do so? Let us consider a by z equal to r. When we'll got a by z, just simply minus, take the minus out, az inverse 1 n. Now let us consider a by z equal to r, and also let n equal to minus k. So if n equal to minus 1, then k will be 1, positive 1. If n equal to minus infinity, then k will be only infinity. so it is converted to the positive limit. Now you can write summation of k, we are replacing n to k is equal to 1 to positive infinity r minus k. We have replaced both of them. Now we know the formula. It is simply r to the power minus 1 r inverse 2 inverse 3, and it will go. Now we can write it as simplified form. To simplify further, we will take 1 by r common. If we take 1 by r common, then it will be 1 plus 1 by r plus 1 by r squared. And by seeing this, we can remember the formula we have already learned. 1 by 1 minus common term. The common term is 1 by r. So here we can also adjust the ROC. The ROC will be modulus of the common part less than 1. So now let's simplify it. The r will be in the top part and rest of will be the bottom part. This will be deducted and the final result will be minus r minus 1. It can also be represented as 1 minus r. So now we have to replace r by a by z. A by z. So z will be at the top and rest of will be at the bottom. This is the final answer, and now let's deal with ROC. The ROC will be modulus of r greater than 1. Now let's replace r by a by z. So modulus of z by a, and then modulus of z is less than modulus of a. This is the final ROC. So the graphical representation of the ROC will be, we are taking a circle of radius a. So it is into the circle. So the radius will be this. So this is the answer. Z modulus of z is less than modulus of a. The graphical representation here inside the a radius circle. So this is the ROC, and here we can see the answer, the Z transform. Now moving to the next part. Yes, the answer is correct. Now this is another very important math, so let's do it. So in this math we are seeing a to the power n unit function un plus b to the power n unit function of minus n minus 1. So there are two different terms and then summation. So it dividing in two parts. First of all, we need to be clear about a term which is un minus 1 minus n minus 1 equal to 1 when it will minus n minus 1 is greater than or equal to 0. So minus n is greater than or equal minus 1, n is less than or equal 1. Sorry, this will be plus 1. Yes. So in function of minus n minus 1 equal to 1 when n less than or equal minus 1. Now let's divide it into two parts. x1z will be summation of n minus infinity to infinity a to the power n u n z inverse n. So we have already did this. So the answer will be z divided by z minus a, and the ROC will be, we know the common term a by z is less than 1, so modulus of z will be greater than modulus of a. Then x to z, let's do for the x to z or the p to the power n u minus n minus 1 z to the power minus n. So here we are seeing n less than or equal minus 1. So if n less than or equal minus 1, then the term u minus n minus 1 will be 1. So to do so, we need to take n equal to minus infinity to minus 1, and here this will be n equal to 0 to infinity. So now b to the power n equal to the into 1 into z inverse n. So we are already familiar with this. We need to convert the negative limit to the positive limit. So to do so, we have to again take n equal to minus k. Then if n equal to minus infinity, k will be positive infinity. N equal to minus 1, then k will be plus 1. We have to also consider bz inverse 1 equal to r. So if we replace in this equation, k equal to 1 to infinity r to the power minus k, then all the things are same as previous. So we are directly writing it. This will be 1 by r. We had taken common the 1 by r in the previous math. Then it will be r minus r divided by r minus 1. So it will be deducted, and the final answer will be 1 by r minus 1. So we have to replace the r b by z minus 1. And finally we are getting z in the upper part, b minus z in the lower part. This is the answer, the z transform. And the ROC will be, simply the common part less than 1. So what is the common part here? B by z. Modulus of b by z less than 1. So z by b greater than less than 1. My mistake. So modulus of z will be less than modulus of b. There are two parts. We have to add those two parts. So how can we add? xz equal to z minus z by z minus a minus or plus b minus z. So this term is also replaceable by this z by z minus b. So if we now write the ROC of both of these together, what it will be? So we are seeing here z is less than b, and from here we can see z is greater than a modulus of a. So in together this can be written as a less than z less than b. So in the slides we have seen this type of problem. This can be represented as r1 less than z less than r2, and the graphical representation is this. So if we sketch the graph will be this radius is a and this radius is b, and this will be the radius region of convergence. So this is the solution, this is the Z transform, and this is the ROC. So now we are stepping into a new topic, inverse Z transform, which is inversely related to the Z transform. So in the Z transform we converted xn to xz, and now we are converting xz into xn again. So this is the core formula, xn equal to 1 by 2 pi z line integral xz z to the power n minus 1 dz. So obviously we will not gonna use this formula, it is very complicated formula. We need to know some formulas, some special cases to solve questions of this level. So the first term will be if del n minus k, then its Z transform will be z to the power minus k, and vice versa. If n plus k, then it will be z to the power k, and vice versa. So if you take an example, xz equal to 3z squared plus 4 minus 2z inverse 1, 3z inverse 3. So this and this is familiar and similar also. So the value of 2 minus k is 2, so k equal to minus 2. So simply you can write del n plus k or plus 2, and it is z to the power 0 if you consider it z to the power 0. So this will be simply del n minus 2 del minus 1 again, so we'll write it as n minus 1, because if the value of minus k is minus 1, that k equal to 1, and then we will write n minus 1. And lastly 3 del minus 3, so it will be n minus 3. So this is the answer. If we represent it in the sequence form, it will be n small x. So if we represent it in the sequence form, it will be simply as 3 0 4 minus 2 0 3. So what will be the start point, or what will be the n equal to 0? This will be the n equal to 0. Why this will be the n equal to 0? Because here we can see 4 plus 4 plus 4, nothing here, so this will be z to the power 0. So here we can see n equal to 0, this will be the starting point. In the left part it will be minus 1, the negative parts, and in the right part it will be positive parts, plus 1 plus 2 plus 3. So this is the answer. Let us solve another problem. So the things will be same, del n minus k, it will be z to the power minus k, and vice versa. So the x of n will be here 0 square, the term is minus k equal to 2, so it will be del n plus 2, then 2 del n plus 1, then 3, so here 3z0, so it will be simply del n, 4 del del n minus 1, 5 del n minus 3. So this is the answer, and if we want to represent it as sequence form, it will be 1 2 3 4 0 5. So how we write it? It is 1 because this is z squared. This is for this del n we are pointing 3 equal to n equal to 0. This will be minus 1 minus 2. Here n minus 1, so it will be n equal to 1. Then we are not seeing any n minus 2, so that's why we are taking 0 as n equal to 2, and then it will be n equal to 3 at last. So this is the answer of this inverse Z transform. For this problem, we have also written the sequence format by using the previous formula. Here n plus 2, so it will be minus 2 minus 1. We are seeing nothing like n plus 1, so there is a 0 we're considering. So at n equal to minus 1, that will be 0. And that in n equal to 0, there will be 4 plus 1 minus 2 plus 2 0, and so on. Now we are starting a new topic which is known as linearity. To achieve this property, let's think of a scenario. If x1 can be converted to x1z, or x1z can be converted to x1n, which is vice versa, and x2n similar x2z and vice versa, then we can write xn equal to a1 x1n plus a2 x2n. If we z transform it, it will be simply like xz equal to a1 x1z plus a2 x2z. Now we will go through some mathematical problem. To do the mathematical problem, we need to remember the previous formula. A to the power n un equal to 1 by 1 minus a z inverse 1. This is Z transform, direct formula. We can use the direct formula from now on. Let us consider an example here. So in this example, we will determine the Z transform and ROC. So we are seeing two parts here. We will divide the two parts. So for x1n, the x1z will be summation of n equal to minus infinity plus infinity. The x part 3 to the power n un, which is separately multiplied by the both terms, z to the power minus n. So we know the term, we have already faced it. This is our a and this is our z inverse n, so it can be simply written as 3 into 2 z inverse 1 n. Infinity, so this will be 0 here because we are dealing with unit function. So a z inverse 1 to the power n, we can directly write it as 2 into 1 plus 1 by 2z plus 1 by 2 z square plus 1 by 2 z cube. the formula. We have already faced this formula. You can elaborately write these things. And now you can call another formula, which is 2 into, this thing can be shortly written as 1 by 1 minus the common part 2z inverse 1. Sorry, there will be no 2. This is my mistake. So the final answer will be 3 1 by 2 z inverse 1. This is the answer or the z transform for the first part. Now moving on to the next part, x to z. Minus infinity to the infinity 4 3 to the power n u n z minus n. So I can directly write it as n equal to 0 to infinity 4 into 3 z inverse 1 to the power n. So if we skip some steps, we can directly write it as 4 1 minus the common part 3z inverse 1. Now adding the both, getting 4 by 1 minus 3z inverse 1 plus 3 1 minus 2z inverse 1. So in the question we are seeing minus, so we have to write here minus. So in terms of writing the answer, we need to bear in mind that how the question is given. Now we have to find out the ROC. So if we take the common part 3 by z, the first common part, it will be less than 1. So z will be greater than 3. For the second part 2 by z less than 1. So it will be z greater than 2. So here z is greater than 3 and z is greater than 2. So the value will be here 4, 5, 6 and so on. And for this it will be 2, it will be 3, 4, 5, 6 and so on. So which we're gonna take? We'll take the big one. So the final ROC will be z greater than 3. If we plot it in the graph, this is a circle with radius 3 and the region of convergence will be excluding the circle, outside the circle. So this is the ROC and this is the answer. Now we will talk about the time shifting. Let us consider a scenario if xn, if we z transform it, it will be simply xz and vice versa. Then x of n minus k will be z inverse k xz. How we have got this term? So let's derive it. If we simply z transform it, n equal to minus infinity to infinity x n minus k z to the power minus n. Let us consider m equal to n minus k. Then minus n will be minus m minus k. So if n equal to minus infinity, then m will be minus infinity, and if n equal to infinity, then m will be infinity. So if we put on the value, if we simply replace it, m equal to minus infinity to infinity x m z. So we are replacing minus n with minus m minus k. now m equal to minus infinity minus plus infinity x m. If we divide z to the power minus m into z to the power minus k. Now closely look in this term or this part. If you observe it, we can see that this and the main formula x and z to the power minus n is the same. So we can write z to the power minus k in z transform of xm. So it can be written as xz. So yes, it is derived. We can simply write, if xn minus k, we have to transform it to the z transform. The answer will be z to the power minus k x of z. This is very important, we need this. So we are on our final stage. This is the last problem we're going to solve. The problem states that using the time shifting property, find the z transform of x2n and x3n using x1n. So at first we have to z transform the x1n. So if x1z will be summation n equal to minus infinity to infinity x1n, so it can be written as, we're seeing the term is starting with the lower value 0, only 0, and the upper value is 0, 1, 2, 3, 4, 5. So this will be 5. So if we write x0, the value of x0 is 1, z to the power minus 0, I am writing it. 0, z inverse 5. Okay, so this is the z transform of x1n. By using the values of x1z, we have to solve the x1n and x2n. So we have x1n as a weapon. By using the weapon, we have to fight with the x2n and x3n. So let's do it. So we are already seeing here the starting point, or n equal to 0 here is 1. If anything is not mentioned or any arrow, then we'll consider n equal to 0 is the first term. And here the n equal to 0 is pointing the 5. So here this is n equal to 0, this is minus 1, minus 2, 1, 2 and 3. So we are seeing here that if there is an arrow, the arrow is shifted to the forward. So it is advancing. So if something is advancing, we can write it as xn plus k. K steps it has been forwarded, it has advanced. If we write x2n, it can be represented as x1n plus 2. 2 steps it has been forwarded or advanced. So we already know the formula here. We can write the formula. Z minus k x of z. So it will be z to the power minus k x of z. The value of k is z minus minus 2. The value of minus k is 2. So we're replacing minus k with 2z square and x1z. So if we just write out the values of x1z, the values were 1 plus 2z inverse 1, 5z inverse 2, 7z inverse cube, z inverse 5. So if you simply multiply it, the answer will be 2z, 5, 7z minus 1, z minus 3. To confirm the value is right or wrong, we can simply z transform the x to n. If we do it x to z, then 1 2 5 7 0 1, this is n equal to 0, so this will be minus 1 minus 2 1 2 3. If we put on the values here, minus 2, so minus 2, if the x minus 2 the value is 1, z to the power minus 2 minus minus it will be plus, so 2, then it will be 2z minus minus 1, so 1, then it will be 5z 0, 7z minus 1 0, and lastly 1z inverse 3, so z square 2z 5 7z inverse 1 z inverse 3. If we compare the two solutions, yes, those two solutions are the same, so we have verified the z transform of x to z. So now do for the x3z. If you closely look to these three terms, if you compare x3n and x1n, we are seeing 1 is starting at here, but there is 0 0, so two terms are added extra. So in x2n it is been forwarded, and in x3n we are saying that it is being backwarded. So if something is backwarded, we can say it delaying. So anything or any signal that is delayed, we can simply denote it as xn will be xn minus k delay. So how many steps it has been delayed? 1 2, so the value of minus k will be the value of k will be 2. So xn minus 2, we can write x3n equal to x1n minus 2. So the z transform of x3z will be z minus 2 x1z. If we put on the values from the previous answer, 1 plus 2z inverse 1 then we are getting the final answer here. So this is the final answer. If we manually do the x3z or the z transform, we will get the same answer. You can verify it by your own. So this is the answer. We can simply do it by taking the x1n and also analyzing the x1n with the x2n and x3n. For the x2n, we are seeing that it has been forwarded 2 steps, and for the x3n, we are seeing that it has been backwarded or delayed 2 steps. So these are the answers. We have to also consider the ROCs here. So if we see the first problem, the x1z, the ROC will be except z equal to 0. Why is z equal to 0? If you consider 2 by z, if the z equal to 0, then 2 by z will be infinity, which is invalid. So the ROC will be enter z plane except z equals 0. For the x2z, we are seeing the z to the power k, also z to the power minus k terms, inverse and the normal terms. So we have to exclude z equal to 0, also z equal to infinity, and the entire z plane will be the ROC. For the last C number question, x3z, we are seeing that only the inverse terms, so the ROC will be entire z plane except z equal to 0. That's all for today. Hope you guys have learned something from this video. This was my first video. Please do share and keep supporting me. Thank you so much.